All right, today we're going to talk about functions. And in order for something to be a function, the definition is a relation. And so remember, a relation is a set of ordered pairs in which no two ordered pairs have the same x coordinate. So in simple terms, basically that means your x values cannot repeat. So remember, your y values can repeat, but your x values cannot repeat in order for that relation to be a function. Okay, so remember we talked about we could list a set of domains, we could list a set of ranges. Remember, domains are your x values, your ranges are your y values. So a lot of times they can be set up in little charts, and sometimes they might be little circles over here, or it might just be a list of them. And let's just say if this goes to this, this goes to this. So from that, you could sort of we can look at that and say, well, all of our ordered pairs over here would be -2, 1, 0, 7. It's the one it's pointing to. 3 is 5. And 4 then is 3. So you notice there that yes, you could say, yes, this is a function because none of those ordered pairs repeat. Now, if you had one that, this 4 also went with the 7, then that 4 is repeating, so therefore it would not be a function. And so we can say this is like a circle mapping. And you can just do these any way that, this is listing. So this would be our circle mapping. This would be our list of ordered pairs here, just listing all those, the ordered pairs in that relation. Then if you were told, you could just have something like this. Is P is equal to, listing all my ordered pairs here, is this a function? Well, all you worry about are those x values. So you can look at this and see, well, they all have the exact same y value. Well, y values are okay to repeat. But the x value does not repeat because our x values here are -3, 1, and 2. So yes, this is a function. So if I list something like r, what if 5, 2, -5, -2, 3, 4, 2, -1, 3, 7. Is this a function? Well, you see here that our 5, we've got a 5, a -5, a 3, a 2, and a 3. Well, these two 3's repeat. So no, that is not a function. And it is that easy to determine given those ordered pairs. Now, functions are sometimes denoted with we call it function notation. And it is written like this. So f of x, which reads f of x, so the function of some x value. Well, that really, this f of x is just another way to write the y. So that really just like y. So if you have an equation, y is equal to 2x, well, you could put f of x is equal to 2x, and that's the same thing. That means the same. So if it tells you something like, if we have, well, let's just use the same one. So if we have f of x is equal to 2x, and they say find f of 1, f of 0, f of 3. Well, that means if I'm looking for f of 1, that means I'm replacing the x with 1. What is y? What's the function? What's the rest of it? So if f of 1 of 2x means 2 times 1, so f of 1 is 2. That ordered pair then is 1, 2. We replaced the x with 1, and then we solved for that as 2. So f of 0 means 2 times 0. X is now 0. So f of 0 is 0. So then y would be 0. So that ordered pair would be 0, 0. F of 3 then means we're replacing that x with 3. So 2 times 3. So f of 3 is 6. And that ordered pair then would be 3, 6. So hopefully that's making some sense a little bit. You can also determine if something is a function, and if it's written in function notation, that means that that's already telling you that it's a function. Another way that we can determine is using the vertical line test. And that is just sort of helpful on graphs. If you're looking at a graph, you can determine if those x values are repeating again. So let's just look at a few graphs here. And let me just draw some random shapes on here. So if I have something that looks like this, well, think about all those vertical lines. Well, these are going to be all my vertical lines that are listed here, right? And so if any of these vertical lines hit this twice, then it is not a function. Remember, we cannot have any of those x's repeat. So we would say, yes, this one is a function because none of those repeat. And sometimes I'll say, like, if you can imagine holding your pencil at a vertical position and running across that and just seeing, does that blue line hit my pencil anywhere twice? All right, versus, let's look at another one. If I had just some random shape on here, maybe like this, I can say, well, does this hit my pencil in any two spots? If I draw all these vertical lines through here, well, you notice it's hitting here, it's also hitting here. That means it's got the same x value for those coordinate points. So no, this one would not be a function. You can also have something where you've got a lot of points here, and if I was on graph paper, you could see, you know, like if I was to label all these points, maybe over here, make sure I line them up so that they're not touching each other anywhere. Well, I can look at that or run my pencil across that or list all those ordered pairs and see if any of those x values repeat. So I could have shapes, I could have just ordered pairs on a graph, and then determine. So, we would say, yes, this one is, because nothing lines up with another x value. But if I had, like for example, if we threw one on here where some of these x values might line up right next to each other in the same, they would have the same x values. So let's say like if that's like -2 and that's 1, 2, 3, well, this ordered pair would be like -2, +1, and this one would be -2, +3. Well, notice they have the same x values, so no, that could not be a function. So it's just different ways to determine these. You can have the circle mapping, you can have a graph, you can actually have a list of ordered pairs to determine if things are functions or not.